Well, China's annual National People's Congress has just wrapped up in Beijing, and the message from the top was for the country to dominate the global tech and artificial intelligence sectors by the year 2030.
President Trump came to office the first time he's been focused on the economic and national security risks posed by one country in particular.
Did you say China? China?
China!
We were losing to China. We want to beat China. We're leading China.
Cornerstone of this plan is for AI and tech dominance in China by the year 2030.
China is building roads right now without a single human being on the construction site. We are talking about machines that work for 20 straight days without stopping. A paver so wide it covers 4 full motorway lanes in a single pass. A satellite system so precise it positions asphalt to within 1 centimeter. And a drone fleet that surveys 158 kilometers of highway faster than a human team could survey 5. All of this is happening right now. While Europe is running small test trials on closed sections and writing reports about what autonomous construction might look like someday, China already has 2 completed projects, 2 broken world records, and a 3rd machine fleet already deployed. That gap between a country that does and a world that discusses is what this video is about. We are going to walk through exactly what China built, exactly how they built it, and exactly why no other country on Earth has come close to replicating it. Some of what you are about to hear will make you question what you thought construction was even capable of. And by the time we get to the end, you will understand exactly why civil engineers around the world are paying very close attention to what is happening in China right now. Let's get into it. There is a highway in China called the Beijing-Hong Kong-Macau Expressway. It is one of the busiest roads in the country. Millions of tons of freight move through it every year. Hundreds of thousands of passengers travel it every single day. It is not a quiet back road somewhere in the countryside. It is a critical national artery, and in 2024, a 158-kilometer section of it needed resurfacing. In any European country, that job means months of lane closures, thousands of worker shifts, traffic disruption that makes the evening news, a timeline measured in seasons, not weeks. China looked at that same job and made a different decision entirely. No workers, no crew, no human being on the construction site at any point during the entire project, just machines. The fleet that showed up to that expressway was built by Sany Heavy Industry, one of China's largest state-owned machinery manufacturers. At the front was the SAP 200C-10, an autonomous paver that had never been deployed on a live national highway before. This single machine laid asphalt across a width of 19.25 meters in one pass. 4 full motorway lanes, 1 movement. No joints between sections where water seeps in and the road starts breaking down after 2 winters. No overlap where the surface builds unevenly and wears faster. 1 machine, 1 pass, 4 lanes done. With a precision that human operators spending their entire careers on a paver cannot match on their best day. Behind it came 10 more machines, 6 13-ton double drum rollers and 3 30-ton rubber wheel rollers moving in a synchronized formation. 1 paver at the front, 3 waves of rollers following, each one compacting the fresh asphalt at exactly the right pressure, at exactly the right moment, in exactly the right sequence. Not because an operator was making that call in real time, because an algorithm calculated the optimal compaction pattern before the first machine moved, and every machine followed it perfectly for 158 kilometers without a single deviation. The brain behind all of it was China's Beidou satellite system, not GPS Beidou. China's own navigation network, fully operational since 2020, delivering positioning accuracy down to the centimeter. Every machine on that site knew where it was to within 1 centimeter at every single moment. The asphalt being laid was more precisely positioned than anything human hands working with GPS-assisted equipment in Europe can achieve, because GPS gives you accuracy in meters. Beidou gives it in centimeters. That gap, 1 centimeter versus 1 meter, is the difference between a road that lasts 25 years and one that starts showing problems in 15. Before any machine moved, drones flew the entire route. High-resolution cameras scanning every centimeter of the existing surface, identifying damage, measuring elevation changes, generating a complete terrain model accurate to within millimeters across 158 kilometers of live highway. What used to take human survey teams weeks to produce was done in days, more accurately than any human survey has ever delivered at that scale. That model fed directly into the machine fleet's operational system. The paver did not navigate by operator feel or years of experience. It navigated by a centimeter-accurate 3D map of every meter of road it was about to cover, built hours before it arrived. The numbers that came out of this project stopped engineers mid-sentence when they read them. 66% reduction in labor, 50% improvement in compaction efficiency per pass, surface uniformity exceeding every quality standard the project had set, and the whole thing finished ahead of schedule. In construction, ahead of schedule is almost a myth. It is the kind of promise that appears in proposals and quietly disappears 6 months in. On this project, it was just what happened, because machines do not have bad days. They do not slow down on Friday afternoon. They do not make judgment calls that turn out to be wrong at hour 9 of a 10-hour shift. They run at the same precision every hour until the job is done. That was 2024, that was the first project. And if you think 158 kilometers with 0 workers is the ceiling of what this technology can do, what China did next will make you rethink what the word ceiling even means. Within months of finishing the Beijing-Hong Kong-Macau project, the same autonomous fleet was redeployed, this time on the Beijing-Harbin Expressway. And this project did not just repeat what had been done before, it erased it. The paving width jumped from 19.25 meters to 25.25 meters. 2 autonomous pavers working side by side, 10 rollers behind them, covering a road surface wider than most European construction projects ever attempt, with a full human crew at full staffing. The machines ran for over 480 consecutive hours, more than 20 straight days without stopping, without a shift change, without a single error accumulating from a tired operator making a bad call at 3 a.m. The machines ran at the same precision on hour 480 as they did on hour 1. Labor dropped 60%. Efficiency increased 20%. The project finished before its deadline. Again, this is not one impressive achievement followed by quiet. This is a pattern. China sets a record, then immediately asks what the next record looks like, then goes and sets that one too. And the rest of the world is still processing the first one. Now here is where the comparison with Europe stops being about admiration and starts being about something more uncomfortable. Europe is not standing still. That is important to say clearly and honestly. European companies like Dynapack are developing what the industry calls road construction 4.0. Digital leveling systems, machine guidance technology, semi-autonomous paving assistance that helps human operators make better decisions faster. It is serious engineering done by serious people. But the critical word in all of it is semi-autonomous. Every advanced European paving system operating on a live road today still has a human in the cab. The machine assists, the human decides, the human gets tired, the human makes mistakes, the human goes home and construction stops. China's system has no human in the cab. There is no cab decision to make. The AI decides. Beidou confirms the position. The machine executes. Construction does not stop at shift end. It does not stop at all. The global autonomous paving equipment market is currently worth $1.89 billion and projected to hit $8.79 billion by 2036. The research identifying those numbers describes Asia Pacific, driven almost entirely by China, as the dominant regional market. It describes Europe and North America as leaders in technology penetration. That phrase sounds positive. It means sophisticated tools that make human workers more effective. It does not mean machines that replace human workers entirely. Europe is very good at helping humans build roads better. China is building roads without humans. Those are not the same achievement. They are not even on the same road. The UK's own highways industry publication covered the 158-kilometre project, and its conclusion was plain. For Britain, the challenge now lies in scaling up existing trials, not matching what China did, not deploying a comparable system on a comparable highway, scaling up trials. France has pilot programs, Germany has research projects, the Netherlands has demonstration sections on closed test roads. None of them have put a fully autonomous construction fleet on a live national expressway and let it run for 20 days straight. China has done it twice, broken its own world record between those 2 projects, and is already on the 3rd. 3 technologies are working together to make this possible, and the combination of all 3 at this scale exists nowhere else on Earth right now. Beidou delivers centimeter-level positioning that GPS cannot match. The AI coordination software manages 10 machines at once, making thousands of micro-decisions every hour that no human site manager alive could process fast enough to act on. And the drone survey system generates terrain intelligence before construction begins that used to require weeks of manual work and still came out less accurate. Europe has versions of each of these technologies in isolation. What Europe does not have is all three integrated into a single deployed system running on a live national highway at full scale. That integration is where China's lead actually lives, not in any single machine in the system those machines are part of. And that lead is not closing, it is widening. China's expressway network already exceeds 183,000 kilometers, the largest in the world, and it is still growing. Every kilometer of that network handed to autonomous systems is more operational data. More data means smarter algorithms. Smarter algorithms means better machines. Better machines means the next project runs faster, wider, and more precisely than the last. China is climbing a learning curve that the rest of the world has not started climbing yet. The gap does not close by standing still. It closes by deploying. And right now, only one country is deploying. European manufacturers know this. The engineering talent to close it exists inside European companies. But development in Europe moves inside a commercial cycle where every step requires private funding, regulatory approval, community consultation, and a business case that makes sense to investors watching quarterly numbers. That cycle takes years between each step. In China, the government funds the research, clears the deployment environment, absorbs the risk of first-of-a-kind technology on a live highway, and mandates scale. The step from pilot program to 158-kilometer live national expressway happened in China not because the risk was small. It happened because the decision was not constrained by the same structures that slow every equivalent project in Europe down to a pace that lets the gap keep growing. A road built this way is also not just faster to build, it is a fundamentally better road. Surface uniformity at machine precision reduces the microscopic variations in the asphalt layer that let water in, that expand and contract through winter, that become the potholes and cracks that cost governments billions every year to repair. A more uniform surface lasts longer. A road that lasts longer costs less to maintain across its lifetime. Across a 183,000-kilometer national network, the maintenance cost difference between machine-built precision and human-built approximation is not a marginal saving. It is a structural economic advantage that compounds every single year the gap stays open. And nobody on that site got hurt. Road construction is one of the most dangerous jobs in civil engineering. Workers killed by passing traffic, by heavy machinery, by the 1,000 ways that putting human beings next to enormous moving equipment on live roads at all hours of the day and night ends in tragedy. 0 human workers on a 158-kilometer resurfacing project means 0 risk of any of that. Not reduced risk, not lower probability, 0. That is not a side note in the efficiency story. That is one of the most important things this technology does, and it barely gets mentioned. The Beijing-Hong Kong-Macau Expressway project did not make the global headlines it deserved. Most people in Europe and North America still have not heard about it. A 158-kilometer highway built entirely by machines was treated as an interesting technology story, and then the news cycle moved on. What it actually was is a signal. A clear, documented, measurable signal about which country is writing the rules of infrastructure for the next 30 years. And most of the world missed it. China is not waiting to see how anyone responds before running the next project. The machines are already on the next highway. The data from the first 2 projects is already improving the algorithms for the third. The record set in 2025 will be broken before most countries finish the regulatory paperwork required to begin a comparable pilot. 0 workers, 10 machines, 158 kilometers, then 25 meters wide, then 480 hours straight. 1 country, and a gap between what China is building and what the rest of the world is trialing that gets wider every single month. Once you see that pattern, you cannot unsee it. This is Signal Core. If this video changed how you see what is actually being built right now and who is building it, hit the like button and subscribe. We cover the breakthroughs that most channels have not caught up to yet. And I want to know what you think. If autonomous road construction becomes the global standard within the next 20 years, which country ends up selling that technology to everyone else? Drop your answer in the comments below. The conversation down there is always worth reading.